All right, I'm going to do a video on permutations now, and then I'll do one on combinations, and I'll post those before week 5, part 2, check for understanding. So let's look here in the middle of the page. The permutation formula is n, choose r, is n factorial over n minus r factorial, where r is greater than or equal to 0 and less than or equal to n. So if you saw this symbol, the permutation symbol 5, choose 3, then or 5 taken 3 ways. This would be 5 factorial over 5 minus 3 factorial, which if I wrote this out is 5 times 4 times 3 times 2 times 1 over 2 factorial, which is 2 times 1. And then I'd have 12 times 5, which is 60. I'm not going to do all these, but there's a question and check for understanding about this. So 4p4 would be 4 factorial over 4 minus 4 factorial, which is 4 factorial over 0 factorial, which is 4 times 3 times 2 times 1. And 0 factorial is defined as 1. So this is 12 times 2, which is 24. So in the video for this week, it said a combination lock should really be called a permutation lock. Will open when the right choice of 3 numbers from 0 or 1 to 30 is selected. How many different lock combinations are possible, assuming that no number is repeated? So then you would have 3p30 or 30p3. So you have 30 factorial over 26 or 27 factorial. Or you could look at it this way. I have 30 possibilities on the first number, and then 29 times 28, which is what would happen here is the 27 factorial would cancel with the 27 factorial up here, and then left with 30 times 29 times 28. And let me get the calculator to calculate that number. So 30 times 29 times 28 is 24,360. So 24,360. Most of the time, when it's a permutation, instead of using a formula, I just do this. So down here with 24 members, so a club of 24 members, you want to pick a president, vice president, secretary, treasurer, and historian. So how many how many ways can the offices be filled? Well, you have 24 possibilities for the president, and then 23. So something just went wrong with my pen. I don't know. Got to figure out what that is because it keeps doing that. So 24 times 23. So president, there was 24 choices. Then there would be only 23 choices. And then 22 for the secretary, 21 for the treasurer, and 20 for the historian. Or you could plug into this formula and you would end up with the same thing once you cancel the numbers on the numerator and denominator that are the same. So 1, 2, 3, 4, 5. I'm going to go to my calculator. 24 times 23 times 22 times 21 times 20. So 5,100,480. All right, I wanted to go over this because if you have repetition, then you have to divide by the factorial of the repeated, for in this example, letters. So the repeated letters. So the number of distinguishable permutation of n objects where one object is repeated s sub 1 times, another object is repeated s sub 2 times, and so on. And you do n factorial over the repeated factorial. So s sub 1 factorial times s sub 2 factorial, and so on, where k is the number of repeating objects. So it says find the number of distinguishable permutations of the letters of the following words. So there's some like this on the checkout for understanding. So what you do is you count the letters in the word. So 1, 2, 3, 4, 5. So you're going to have 5 factorial. And then the factorial in the denominator is the repeated letters, and I'll multiply them together. So there's 2 m's and 2 i's. So 2 factorial times 2 factorial. And you can just use your calculator for that. But one thing would happen, I would have 5 times 4 times 3, which is 60 divided by 2. So this answer is 30, but I'll show you how to do it on the calculator. So going to the calculator. If I, let's get rid of this. If I hit the division key, then it'll give me the fraction bar. So I have 5 factorial in the numerator. And go back to the problem. And 2 factorial times 2 factorial in the denominator. So I get 30. And that's what I wrote here, 30. So for Virginia, you're going to count the letters 1, 2, 3, 4, 5, 6, 7, 8. They got 8 factorial. In the numerator, and then the repeated letters. There's 3 I's. And that's it, I think. No, they're repeated letters. So this would be 8 times 7 times 6 times 5 times 4. Because 3 times 2 times 1 would cancel with this here. So 8 times 7 times 6 times 5 times 4. Or just putting it on the calculator. 8 factorial. And then divide by 3 factorial. Is 6,720. All right, and then Tallahassee, got the letters 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then there's 1, 2, 3 A's. And 2 L's. And 2 S's and 2 E's. So I'm going to the calculator now. Oh, 11 factorial divided by 3 factorial. And then times 2 factorial. Times 2 factorial. Times 2 factorial. So 831,600. so the rest of the examples on the page. How many different license plates can be created if the license plate has 4 letters followed by 2 digits? And the items can be repeated. Would be 26 times 26. So 4 letters. 26 4 times. Oops. And 10 twice. So 0 through 9. And so I get my calculator, 26 to the 4th. Times 10 squared. Is 45,697,600. $697. And then can be repeated, or cannot be repeated, would be 26 times 25 times 24 times 23 times 10 times 9. I'm going to the calculator. 26 times 25 times 24 times 23 times 10 times 9. So 32,292,000. I'm going to skip this section here. It's just a matter of plugging into the formula. And then for yellow, I'm just going to set these up here. So 1, 2, 3, 4, 5, 6 factorial. And there's 2 repeated letters there. And for Panama, 1, 2, 3, 4, 5, 6. So there's 3 A's. And this one would be 6 times 5 times 4. So 30 times 4 is 120. And then this would just be 120 times 3, 360. Then Honolulu has 1, 2, 3, 4, 5, 6, 7, 8 letters. And then 2 O's. And 2 L's. And 2 U's. And then finally Mississippi, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then 1, 2, 3, 4 I's. 4 S's. And 2 P's. All right, and so let me use the calculator now. So 8 factorial divided by 2 factorial times 2 factorial times 2 factorial. And 5,040. And then the last one in this row here, 11 factorial I'm going to divide 4 factorial times 4 factorial times 2 factorial. Get 34,650. All right, Spanish Club is electing president, vice president, secretary. The club has 9 members. You're eligible for these offices. How many different ways can 3 offices be filled? So it's going to be 9 times 8 times 7. So 72 times 7. 504. 504. And the final question here, the window of a music store has 8 stands in fixed positions where instruments can be displayed, and how many different ways can three identical guitars, 2 identical keyboards, and 3 identical violins be displayed? So you got 8 factorial for the stands. Over 3 factorial times 2 factorial is 3 factorial. So 8 factorial divided by 3 factorial times 2 factorial times 3 factorial is 560. All right, I'm going to stop the video there for the permutations, and I'll come back and do one on combinations.